of the tool. All these, once we understood the procedure, I think you can able to do any kind of the programs or problems from CNC machines. So there are two basic types. One is a CNC center, that is CNC turning center and CNC milling center, and another one the CNC drilling and pack drilling and gang drilling. All these are the some of the things. Once we know the G code and M codes, and the sequence of operations can be analyzed, and you can do the programming later. And that is not, I feel it is not so important part of it. The important part of it is that some of the quiescent things which are within the CNC machines, which we have to understand them. And some of them, once we understood the program, and we may feel that it is not necessary, but it is very, very important to understand. Okay, so all those theories we'll try to study them. So under the scope of this numerical control systems, we have the introduction to that and component of CNC machines, CNC programming, manual part programming, G codes, M codes, and programming with the component of turning, drilling, milling systems, and CAD cycles, and cutter radius compensation, tool length compensation, and all these will be studying them. And apart from this, these will be say in our laboratory also, maximum viva questions will be asked from this particular chapter only. So all you have to give much more attention in understanding this. Okay, and anyone is waiting? Yeah, if anyone is waiting, please let me know. Okay, and these numerical control systems, they have taken birth in around 4 decades back, and they were numerically controlled. The controlling all the activities of this machine will be in the form of numericals. The numerical instructions will be given as input, and the tape reader will be reading it, and the proportionally the output will be, or the machine will be accepting these instructions, and the machine coordinate movement will take place. And initially it was very, very simple. Later on, when it has been implied in the machining activities, it has taken very good strength in the industries. Okay, and apart from this CNC, computer numerical controlled machines, in its simplest way, which will be having one screen. On this we can be able to visualize the activities and operations, and under there will be a keyboard. Through this special made keyboard, we are going to enter the codes, the instructions which are required to move or command the tools. Those instructions will be given in as an input by using the keys. And the important thing is the interfacing device. The interfacing is called machine control unit. Machine control unit will be there. That we'll discuss later. So in case of this, there will be one computer and there will be machine tool in CNC machines. Anyone, if they can able to visualize it, this will be a CNC machine. And in case of Dnc machines, just here only I'll be giving you a small introduction to the Dnc systems also. Okay, I'll be giving you a small introduction to Dnc systems also. You can see that. In this CNC, it is computer numerical controlled machines. And in its simplest form, it will be having one mainframe computer, and it will be having a connectivity with the machine. The machine will be receiving the instructions from this, and here I write this as a machine. The machine will be receiving the instructions, and which will be performing the machining activities, and we are going to give the input by means of a key. This is how, okay, this is how we show it as a CNC machine. But in case of DNC systems, in case of DNC structure, DNC is direct numerical control machines. And very important, please try to understand the concepts. So there will be, please look here, whatever, for example, this machine is a milling machine, for example, the milling machine programs will be written here, and these milling machine programs will be executed in this computer, and the block of informations, that is called block of informations. The block of information in the sense, one particular sentence which is meaningful, that will be sent once at a time. Once after completing this, a second meaningful information will be sent, like that the third information will be sent. So the machine will be performing these activities. But here in this case of DNC systems, there will be a mainframe computer. There will be mainframe computer. And this you can see that here we will be having please, Oliver, you can able to look at this?
Yes, sir. It's visible, sir.
And try to understand the concepts. These concepts are very, very important. I'll try to make you to understand this. And if you happen to visit any industries, if they ask you, they can see, look here, this is milling machine 1 and this is milling machine N. Is it drilling machine 1 and this is drilling machine N, and it is the lathe center, turning center 1, and this is turning center N. Like that, so many machines may be there. Please understand here, each machine, see here, a single machine will be having a mainframe computer. That particular mainframe computer will be having a specific program to run this machine, and there will be input. The input device, in this input device, the programmer is going to write the program. He will be inputting into this. And certainly what happens, this particular application software will execute it, and the block of information will be sent to the machine, and the machine will be executing it. So in case of this CNC machine, you can see that one machine will be having one mainframe computer. One machine will be having one mainframe computer. But in case of this DNC system, please look here, the DNC system structure is like this. And there will be mainframe computer, and under this so many machines, the entire around more than 100 or 200, the machines may be operated by using this particular DNC systems. And this is having mini frame computer, mini computers. All these will be mini computers. And what is the difference between this CNC system and the DNC system? I wanted to make the differentiate and tell you before I let into this chapter. And in this particular DNC system, this particular mini computer will be having the application softwares. See, each particular, for example, you say one milling machine 1 or milling machine 2 or drilling machine 1, drilling machine 2, whatever you say, all those will be having one mini frame computer. That mini frame computer will be having the application softwares which are meant for this particular machine only. And here it may have some general this information also it may have, but here it will be having only certain programs which are required essentially for to run this machine. Those will be there, and sometimes some of the programs which are required in between, oftenly those will be sir ready sir. You understood my point? So each computer will be having a mini frame computer, and this particular mini frame computer will be having the application software which are essentially meant for this only. Okay, and the mainframe computer will be having the programs which are sometimes required for all these machineries. So that means in case of DNC, the direct numerical control machines, the more this one, the storage system is not required for all these mainframe computers. You are understanding my point, I think. The storage systems are not required. Okay. And what happens whenever that particular application software required, that application software will be executed by this mainframe computer, and it will be executed here. So that means the mini computer which is attached with this, which will not be having much burdensome programs along with this. And another one thing is that these computers and the machines should be within this particular floor only, in the floor level only. But in case of this DNC system, these may be operated by tele-operated fibers. That means we can have this particular station, the operator may be sitting 1 kilometer from the fabrication shop, the machining shop. Okay, it will be tele-operated, and the person who is sitting, he need not to sit near to the machine, and he can do the program here, and all these programs can be executed. That is the strength of the DNC systems. Okay, please ask me any doubts are in this. Gagan, Ashok, Chetan Kumar, Varun, any problems?
Sir, nothing, sir.
No doubt, sir.
Okay, and this is what the differences I wanted to tell you. Now, let me come to this CNC technology. CNC technology, and in this over this 25 years, a lot of changes have been taken place. And what are the basic components of NC system? What are the basic components of NC system? You can see that there are 3 basic components of NC system, and frequently these questions will be asked everywhere. In the final examination also, even in the test also, many times these questions will be repeated because this question is very, very important. What are the basic components of numerical control systems? There are 3 important components of numerical control systems. One is the part programming instructions, or simply we can say program of instructions. The second one is machine control unit, or we can say it is MCU, and another one machine tool. Okay, please remember the program of instructions, machine control unit, and machine tool. These are the three important components of the NC systems. These are the 3 important components of NC system. Now, let me just try to go through one by one. What are these NC components? See, this particular thing, the program of instruction. The program of instructions will be written in a tape. This was earlier it was 1/2 inch wide tape. Then it has converted into magnetic tape. Then it is the microchip, the high version magnetized tapes, all these tapes will be used for the writing the programs. And here the program of instructions which are written on this, those are written based on the type of geometry we are going to machine. Okay, that means the person who is going to write the program of instructions should have a capability to read the drawings, what kind of machining he has to do. Based on this, the program of instructions will be written in the punched tape. Okay, the next one, machine control unit. Machine control unit is a heart of the NC system. What happens here in this NC system? In the previous class, I had given a very simple example, and whatever the program of instructions which are written here, directly if you give it to the machine cannot able to understand it. Or whatever the informations are required for this machine, directly we cannot take them from the program of instructions. So there must be something, interfacing device which can able to convert this the program of instructions which are written on the magnetic tape, okay, into some other form which can able to easily understood by a machine tool. Okay, so this MCU, machine control unit, which will be converting these punched tape instructions written in the other form which the machine can able to understand this. Okay, and this is one, and apart from this, many other important functions are there. You can see them. This punched tape, the machine control unit will have a tape reader. The tape reader is one which will read the tape, the series of instructions, the NC instructions which are written in the tape, in the punched tape, that will be read by a reader. Just like our tape recorder was there earlier, a small cassette we are going to drive it. On the tape, what happens, the header will be reading it, the magnetic tape, electromagnetic tape which will be reading the header, and it will be converting into sound waves later on. In the similar way here, in our machine control unit, there will be a tape reader. This tape reader program, the main important function is to read this punched tape, okay, read this punched tape. And these informations will be converted to some other form, and these informations will be sent to the data buffer. The data buffer function is to store these informations in the block form. What happens, whatever the informations which are given, directly we send it to the machine. What happens, the tape reading capacity and the machining capacity will not have very good synchronized movement. What happens, the machine, it will be taking its own time to execute these programs. So until then, what to do, whatever the informations which are read by the tape reader, that will be stored in the data buffer. And once after one complete information is completed at the machine control machine, what happens, the next block of information will be sent to the machine. That is the main program or function of the data buffer. The main function of the data buffer is to store the read informations are read by the tape reader. Those informations will be stored in this, and these informations will be retrieved one by one logically. What happens, once a complete block of information is executed in the machine, then the second block will be sent, then the third block will be sent. Until then, all these informations which read by the tape reader will be stored in the data buffer memory. That is the main function of the data buffer. The second one is the signal output channel to the machine tool and signal input channel to the machine tool. That is the feedback. The signal output channel to the machine tool is that those informations which read by the data buffer, those informations will be sent in the form of a block through this particular output channel from the MCU, okay, to the machine tool. And these will be executed. And another one thing is that it is a completely closed loop system, and there will be servo control system, and those servo control system will be looking into whether these particular instructions are sent through this input channel have been executed or not, or if they are executing, what is the position, and these instructions will be sent in real time to this data buffer by means of a feedback system. Okay, by means of a feedback system. These are the four important components, sub-components of the control unit. Once again, please remember basically the CNC computer numerical control systems will be having three important components, main components. The first component is the instructions, okay, the program of instructions. The second one is MCU, machine control unit. The third one is machine, or a machine, or we can say it may be a milling machine, it may be a drilling machine, it may be a center lathe. Okay, and what is this the program of instruction? The program of instructions will be written in a punched tape. The varieties of tapes are available: 1-inch tape, and the magnetic tape, and the electromagnetic tape. So many other devices are there. On them the punching will be made, and these instructions will be written in a punching machine. The punching machine is one. This punching machine will be used to create the hole in this tape. And one thing, please remember, once this particular punch tape is used, and if you want to go for the second type of programming, if it is possible to do small modification with the available punch tape, what happens? We can do small changes with the punch tape and we can use it, or it have to be disposed. Once it is used, it cannot be reused once again for some other type of programs. This is one of the disadvantage. Okay, this is a manual type of punch, this one, okay, punch tape method. And once this particular the punching is over, these instructions will be sent to the machine control unit. Machine control unit will be having four important components. One is the punch tape is there. The instructions which are written in the punch tape has to be read by something else. These instructions will be received or retrieved from a device called the tape reader. The tape reader is one which will read the tape, and those instructions written in the punch tape will be converted into form which the machine can able to understand. That is the main function of the tape reader. And once these informations are read by, then where it will be going? It will be sent to the data buffer. The main function of the data buffer is, as and when the informations are required by the machine, these will be sent to the machine logically in the form of a block one by one. Once a particular block is executed completely, then the second block will be sent. Once this particular block is executed completely, the third block will be sent. Okay, third block will be sent. Like this, the informations will be sent. Okay. And the data buffer, what happens? This will be storing the informations as and when it is required, it will be retrieved, it will be sent to the data buffer. Okay, this is one. The data buffer will be sending the information to the machine tool through a proper signal output channel. Okay, this output channel is a wiring system. Through this, the block of information will be sent to the machine. And while it is executing in the real time, what happens? The informations are executed, or they are in the what position, and whether it is completed. All these will be received or retrieved by the servo system, and a feedback will be taken to the buffer, data buffer. Why it is required? Once a particular informations are completed, then the next the set of informations have to be sent to the machine. For that, this feedback system will be helping. Okay, these are the 4 important functions, sub-functions of the control system. Okay, and the next one is the machine tool and other control systems. The machine tool is one. Please do not get confused. If you are going to use the lathe, it is a central lathe machine, the CNC lathe. If it is a milling machine, CNC milling machine. If it is a drilling machine, CNC drilling machine. Okay, that particular drilling machine, along with it will be having a spindle, a control motor to control all the activities of these. Drives will be there, and the servo motor will be there. Okay, servo motor. You can see this. This particular machine will be having, for example, I want to, for example, I have this particular machine, and in this machine there will be a threaded something, for example, and this will be a machine head. A machine head will be having milling set. Milling set will be there, and this will be moved left and back. Okay, and this can be rotated so that it will be moved left and right. And this is a driving motor. This will be a driving motor, and this will be servo motor. The main function of the driver is it will be receiving the instructions, hence it will be rotating it. And whether this is rotating properly or whether the input is executed properly or not, that will be taken by a servo motor, and this servo motor will be sending the feedback to the buffer unit, to the machine control unit. Once a particular block of information is completed, then what happens? The information will be sent back to the buffer storage, and this buffer will be sending once again a block of information. Please remember here, the block of information is a complete meaningful sentence or a statement. It is a complete one meaningful statement which is required to complete one machining. For example, you say, I am going to do one milling, for example. In this particular job, I want to do a milling. I want to do a milling of this kind, for example. I want to do a milling of this kind. Okay, and I want to do a drilling in this, for example. This is what I required. So initially what happens, the milling cutter will come to this position, and a program will be executed to complete this one profile by 1 mm depth it will complete. This is called one meaningful block of information. And the second block of information is, once this is moved 1 mm inside, again the second step it will be continued. The third step will be continued. Like that, after so many sequence of operations, this particular depth will be completed and we get the output later. So for each one complete cycle, this is called one complete cycle. And again it will get into a depth of 1 mm, and again the second complete cycle, and go to the depth of under 1 mm, the third complete cycle. Like that, this one cycle will be called as a block of information. It is called as block of information, and these block of information will be executed. Once the particular block of information is executed, then the buffer unit will be sending the next block of information to the system. Okay. And along with this machine tool, there will be so many other systems will be there. The fixtures will be there, the tool holding devices, and there will be so many the tools will be there. But here, in case of manual drilling and manual milling machines and all, manually you are going to change over the tools. But in case of CNC machines, we are not going to change over the tool manually. It will be done automatically. And which tool is required, that tool will be specified by the programmer himself. The programmer himself will be specifying which tool is required. One can able to see this. There is a drive system, a table is there, the table, and there will be job holding devices, and there will be a tool holding device, okay, and so many tools you can find, and these are called the stations, tool stations. And here so many reamers will be there, drilling machines will be there, the drill bits will be there, and there will be reaming tools will be there, and there will be a cutters, different varieties of diameters cutters will be there, and each one will be called as one station. And now here the CNC machine will not understand. For example, here I am going to keep 10 mm drill bit, and instead of keeping the 10 mm drill bit here, I am going to keep the 10 mm drill bit here. And this particular station will be not called by the 10 mm drill bit. This will be having, the machine will be having its own specific name for this. For example, the tool 1, tool holder 1. And the programmer, he has to understand what the tool is there in the tool holder 1. Okay, then only he can able to write the tool holder number. For example, the 90th tool holder he called for, the 90th tool holder may be having river, he may be required. So like that, the different this one will be there, and the tools can be easily changed by the CNC machine automatically. Automatically, the CNC machine will be changing the tools. And another one small observations while we come to the next, I'll tell you. Please look here. This will be having the machine table, not like ordinary milling or turning table. It will be having its geometrical coordinate system. Okay, the manufacturers will be fixing the geometrical coordinate x0, y0, z0 on a particular page. So that is the machine coordinate system. Okay, machine coordinate system, and this is called the tool coordinate system. And the programmer, what he has to do with respect to the machine coordinate system, how the tool should be moved. For example, this is a z direction movement, how much distance have to be moved, and what should be moved along the x-axis, and how much it has to move along the y-axis, and how much it has to get into the depth. All these will be the programs given by the programmers later on. Okay, and this is how. Now, what is the NC procedure? In order to utilize this numerical control machines in the manufacturing activities, please understand, these NC machines are not only meant for the machining activities. The NC painting machines are there, NC wood cutting machines are there. Earlier the designer was doing the designs by his own architect work. Today the input drawings will be given proportionally based on this, it will be giving you the machined output. Okay, we are going to use as the wood in the wood industries. These NC machines will be used around. You might have seen so many designs. The statues can be made by using these NC machines and NC painting machines. Okay, and even today you can find so many industries they are running. There will be the other. Please understand, I may be asking you sometime question. The other applications of NC systems apart from the machining activities, NC painting and NC